I mean, I was chatting with some science students recently, and we were discussing what makes a theory scientific. And I guess we're drawing on Karl Popper's idea that really a scientific theory has to have at least the potential of being falsified. And the discussion had really kind of come up because...
You mean disproved?
Yeah, at least it has the potential of it.
Okay.
It may not actually be disproved, or it may be disproved and then developed further. But at least a scientific theory has to have that potential, because in his mind you can always confirm things. You know, you can always find evidence to confirm whatever your theory is. So confirmation actually isn't, you know, as defining or as sure for a theory as being able to be disproved, which seems, it's actually interesting, it's counterintuitive, isn't it?
Yeah.
And his point of view is, don't be afraid if your theory has a chance of being disproved, because actually the more chance it has of being disproved, the better theory it is, because it means it's taking more risks as a theory.
Yeah.
You know, if I say, my theory is that this glass has got water in it. Okay, now there's a chance of disproving me. But it's a pretty safe one, you see. Because, you know, but, you know, if, actually I don't think that's a good example at all. Oh, you're going to have problems. You're going to have
no. This is interesting, but let me try and take this on a slightly different tack and see how this comes. Let's see how this comes through. Let's just experiment with this, play with this a minute. You see, I've always been curious why scientists need to prove things in order for it to be accepted scientifically. Now that may sound slightly odd, the way I've presented it, but it seems to me that, you know, this need for proof, this need for evidence in itself is, I think, you know, undermines not so much undermines the value of it, but in a sense, yes, it does undermine the value of it, because, I mean, let me give you an example. I mean, supposing, right, that we ask a scientist to prove gravity, okay, or to prove electricity, or to prove radio waves. Now, obviously, there are ways of measuring that. I don't know if there's a way of measuring gravity. But, you know, it seems to me there are certain things that are, if you like, life-enhancing in the sense that we derive benefit from them, right? Electricity is an obvious one, that you know, doesn't need any sort of proof. I mean, the proof is the experience that it works, rather than some sort of test to say, well, now I've got this theory and there it is, and I've proved it, and I've satisfied all these people who are out there, and then you know, so what? I mean, what's the point?
Well, I don't begrudge someone wanting to have a field of knowledge that is based on theories and experimentation, research, and testing those theories and coming up with something that they can, you know, feel has a measure of fact.
Well, what's the point? That's what I'm saying.
Because those processes are actually quite good at gaining information at how to manipulate material elements through physics and chemistry.
Right.
You mentioned, you know, what's the point of understanding electricity to that degree? Well, the benefit, they would say, is that we then understand electricity to the extent where we can employ that in a lot of different forms of technology. You know, from computing to communications to MRI scans. You know, this is all because we understand electricity, and actually, and probably a little further into, you know, quantum mechanics as well.
Yeah.
So, but there's nothing wrong with saying we're going to have this branch of knowledge which is dealt with like this. I think the big problem comes, and I think this is where your problem is also with it, that when you say that's knowledge, that's real knowledge, and anything else outside of this little box can't be counted as proper knowledge.
Yeah, I mean, I think there's another element here. I mean, correct me if I'm wrong, but my understanding is that science seeks to prove, if you like, in the material world. So there is this material element. That's why I mentioned the examples of electricity and gravity, because I wanted to give you examples of things that you can't actually physically see, you know, and not I mean, obviously you can experience it, but not physically see with five senses and so on. This is, for me, you see, this is why I think science, in a way, falls down and is a disservice. Because when it comes to anything invisible, science doesn't seem to have any means of doing that. And to set out to prove something, in fact, is actually taking the whole thing back a stage. It's almost like, you know,
well, it really
retrogressive.
is. I mean, it's like me saying, I can only have experience and prove the existence of the things in this room. You know, because I can see them, I can move about in here, and I can test it. Therefore, I have knowledge, and I have, you know, I can build up a huge database of research on everything in this room. But because I'm in this room, I can't have any understanding of anything outside of this room.
Why not?
Because I'm saying I'm in this room, and therefore anything outside of this room doesn't exist. That's the approach that science
you've illustrated in a sense
exactly.
the problems.
That's the problem that I think science faces.
Yeah.
Because it says I'm only going to accept what I can prove, and within
my box,
and within the box that human society always is in, and it's always in a box at some point.
Yeah, okay.
Well, and if you say, you know, with inductive science, you're always going to be within a box. You're always going to be only able to see what your senses, your eyes and other senses can have, or what your instruments can test. You're always going to be limited by that box of perception. And it's always external information that you're gathering.
Yes.
And almost as the further we appear to get away from ourselves, the irony is that we lose the ability for our inner wisdom and our inner insight.
Absolutely. And that's my concern, you see. So my question is, in the 21st century, you know, why do we need to prove things scientifically anymore? I mean, what is the purpose ultimately?
Well,
what is the purpose?
My point would be that I think people can, you know, quite reasonably say there is a purpose, and that is the development of technology. You know, the scientific method does seem to serve us quite well if our goal, or if one of our aspirations...
Well, you mean this technology works or it doesn't?
Yeah, and we can develop the technology, you know, quite considerably. Just look at what we have done with the knowledge of electricity, you know, through electronics to computing, etc. So it obviously, you know, has a use. The problem comes when you say that's all there is, because this type of way of gaining knowledge has shown certain benefits and uses. Therefore, you're saying every other way of gaining insights and understanding isn't important. That's where I think that the system falls down.